The broadcast is now starting. All attendees are in listen-only mode.
Ladies and gentlemen, we're still waiting for people getting into the webinar. Please give us 1 or 2 more minutes before we start. Thanks. We will be starting in 1 minute. Please stay tuned. Thank you. Ladies and gentlemen, a very good morning or good afternoon, good evening, depending from where you are listening with us or afterwards. Welcome to the webinar, Key O&M Considerations in the Pre-Connection, Early Operation and End of Life Phase. I've been looking forward very much myself to this webinar, as we usually start to and think about O&M related to the operational phase and forget to think beyond that. My name is Stefano Kruku. I'm a project manager at Solarplaza, responsible for a couple of our conferences, and I'll be introducing our speakers of today shortly, representing two market leaders, SMA and First Solar. The topics of today, as you've probably seen when you signed up for this webinar, are the following. Pre-interconnection phase, what should be in there, what are the hot issues and how does it relate to the operational phase. O&M priorities and best practices during the first years of operation. And we'll also be discussing the service considerations related to a plant's end of life phase, and it might seem still far away for most of the solar plants out there, but it's at least intelligent and very good to start understanding the issues that we will be facing. And the additional topics will be your questions. I would like to motivate you to leave your questions already during the webinar on the right-hand side in the chat box, and we'll be doing our best to address them. Our first speaker of today, as I already mentioned, represents SMA. His name is Jamie Murawski. He's Senior Manager O&M for North America. So he's responsible for all operations and budget for SMA's O&M and preventive maintenance contracts. He oversees the SMA Solar Monitoring Center, and worth mentioning, he brings with him 21 years of experience in power generation, field service, controls and operations in different energy sources. Our second speaker will be Stephanie Padgett, Director of Sales for the Operations and Maintenance part of the business of First Solar. She leads the company's sales strategy with a dual focus on both First Solar projects as well as third-party utility-scale PV plants. She spent the majority of her career supporting and being involved with utilities, IPPs, municipalities, and investors. And previously, she had roles at GE Power Conversion and ABB, the Power Products Division. So I look very much forward to hearing both of you speaking, Jamie and Stephanie. Before we start, a small sidestep. Most of the people signing up for the webinar will know us, Solarplaza. We are now 11 years old, organized over 70 events worldwide in more than 20 countries, and our network of solar professionals is growing each day. I want to shortly mention the conference Solar Asset Management North America, taking place on 16th and 17th of March in San Fran. It's the 3rd edition already. The conference is part of our global line of conferences focused on the operational phase of solar plants and portfolios, taking place in Japan and Europe as well, and we'll be shortly announcing a new country and region where we are extending this line to. 2-day conference, over 60 speakers and more than 400 participants, supported by almost all of the leading companies in this space. And very good to mention, the early bird discounts for this conference is ending in 2 days from now. So if you're still thinking to sign up, you can make use of that. As I said, more than 60 speakers representing the residential, C&I, but also utility skill segment, and we aim to cover all the relevant topics in the operational phase across the segments. Short list of companies attending so far, not updated, I can guarantee. And this year we've added the day after the conference a very interesting project visit to the Alcatraz Solar Plus Storage Facility. It's a 300 kilowatt peak system with storage batteries operational. Great way, fully arranged, great way to get first-hand insights. Fantastic networking. As you can see, obviously it's not the 400 participants here, which I just copied from the previous slide, but it's actually limited tickets. 25 people can join. There are still a few places available. Interaction. We would like this webinar to be not only me or the other people speaking, speaking, but also have input from your side, which means, again, your questions, please shoot them over on the right-hand side, or there are also any technical issues that might be there, although I hope not. And we will also be having polls during the different presentations and in the discussion on the end of live phase, so to check on your involvement now, and because we're very curious to see the thoughts and inputs from the audience as well. Good. Let's start with the first speaker of today. Jamie, we will be making you presenter in a couple of seconds, so let me unmute you. See if we can hear you now.
Yep.
Awesome. There we go. You will have a request right now to share your screen, and we will put up the poll later on when you tell us. Please go ahead.
Okay. All right. Stefano, can you see it now?
Nope. I can. Yes. Excellent. Now I see your screen. Go ahead.
Okay, great. All right, let me just get rid of that. Okay, great. Thanks everybody for spending the time today and going over this presentation. So what I'm going to discuss is grid emulation and the importance of pre-commissioning services. My name is Jamie Murawski. I'm the Senior Manager for Operations and Maintenance in North America for SMA. SMA is a global organization, 30 plus years of experience in the industry, over 40 gigawatts of PV inverters installed worldwide, over 14 plus gigawatts of central inverters installed globally. We're the #1 PV service provider in the US and globally, and the most preferred inverter brand in the world. And we do have a comprehensive service portfolio, which includes grid emulation, which we're going to discuss here, commissioning, preventive maintenance, extended warranties, and plant-wide O&M services. So I'll get started with the meat of the topic, grid emulation. So what is grid emulation? Grid emulation is a service that SMA developed about 2 years ago to meet the complex needs of our large customers and being able to get final completion and construction activities wrapped up on certain large projects that had delays built into them. Some of them which weren't caused by the installers or the commissioning crews. A lot of it was due to the utilities having delays on their side, either building a substation or providing the resources to turn on power in a timely fashion. It's definitely a game changer in the way the large-scale utility plants are tested and powered up. Essentially, what SMA does is the electrical grid is emulated prior to commissioning and interconnect. What this allows is you to fully test and pre-commission the entire power path from the PV panel, the DC side, all the way through the inverter to the medium voltage section of the plant. You know, all these large PV plants are extremely complex, so potential issues are present in pretty much every circumstance. In 100% of the plants that we have performed grid emulation on, we have found significant issues with those construction activities that have happened, anywhere from missing fuses and transformers, phases swapped, DC issues, substation issues, and basically, you know, anything that you can think of, we found issues. These large PV plants that we've done grid emulation on. And the issues are identified and mitigated prior to affecting the commercial operation date. And you know, COD dates are, there's a lot of liquidated damages usually associated with that. So finding these issues before the COD date can make a big difference in the out-of-pocket expenses, either for the owner or for the EPC. It mitigates a lot of risk. To date, we've done you know, hundreds of megawatts of grid emulation. In one instance, we did over 100 megawatts in less than 5 days, and that's a significant amount of activity done in a very short period. And it really proves the fact that grid emulation is a service that really works and is an effective tool for our customers. What are the benefits of grid emulation? It's designed to speed the path to energization, so the operational phase begins sooner, and the project owners begin you know, recognizing and returning their revenue on their investment much earlier. It basically reduces the risk of delays after the intended COD date. It avoids the risk of liquidated damages if the operational dates are not met, which can be very costly. Increased opportunity to achieve an early completion bonus if that's so structured in the contract. And it paves the way for a successful O&M handoff. We use the same personnel for doing grid emulation as we do for our field service work, as well as those that are involved in our O&M activities. So we have an intimate knowledge of what to look for, and we can really tell what's going to happen to be effective O&M in the future for all the activities that are going on. It also eliminates the errors and identifies issues up front, allowing the operational phase to go smoothly and avoid potential system downtime. So you get better quality control and a reduced O&M complexity when you start to run the plant.
Jamie, before you continue, is it a good idea to do the poll right now? Because I'm curious to see what the audience, the experience from the audience is. So I'll ask my colleague to bring it up. 1 second. Okay, so everyone should be able to see the question. So this is for either if you're a developer, an EPC, an O&M provider, or an investor. It talks about the plans you are involved in. The question is, how often do you discover issues post-commissioning that you wish would have been corrected, discovered and corrected pre-commissioning? So if everyone can just click what is true for him or her. Options are never, roughly 25% of the time, half of the time, 75% of the time, and 100% of the time. I'll give a couple more seconds, and I'm curious to see, Jamie, how often this is the case, and then you can. It helps to justify the relevance of the grid emulation services for sure. I think I'm looking at my colleague. Shall we stop the poll and look at the results? Okay. So here you go, Jamie. Most of the people say 25% of the time, but still more than 1 on 10 says 100% of the time. So I think this is good input and shows the relevance of what you work on. Is this also your experience? You just mentioned 100% of the time. Is this representative for what people say that you talk with when you present the service?
Generally, you know, it depends on who you're talking to. If you're talking to an owner, a lot of times the owners don't know all the problems that are going on. Generally, if we're talking to the EPC, they understand the importance and the complexity, and usually from an EPC side, it's close to 100% of the time that they expect to have some sort of issue, you know, from the construction crews.
Okay, good. Thanks to all for your input. Let's continue. Jamie, go ahead with your presentation.
Okay. Thank you. Okay, so this is a basic diagram, a simple diagram of how grid emulation works. On the top, you can see basically a 50-foot flatbed trailer, which has the major pieces of the grid emulation hardware on them. Has a medium voltage transformer and a load bank on it. What you don't see is a generator. The generator that's generally used is a very small generator, usually less than 10 kilowatts. That generator is usually providing power to the inverter and or the load bank to provide the control power for both those devices, so we can actually do the grid emulation. Basically what happens is, you know, you see the block diagram starting on the left. You're basically testing from the actual PV array through the combiners, disconnects, any recombiners that may be in there, into the inverter, out to the medium voltage transformer that inverter is connected to. And then the grid emulation components are the separate medium voltage transformer, the load bank, and the small generator. And you can see basically what we're doing is turning the inverter on and testing the entire path all the way up to the grid connection. If the substation is installed and completed and you're just waiting on the utility connection, then you could feed power into the substation and at least, you know, apply voltage to the equipment in the substation. A lot of times these services are being done before the substation is completed. So what would happen is groups and blocks or loops of the medium voltage circuit would be tested. Generally, they're isolated at the individual group or bank or loop disconnects, AC disconnects for each zone. But there's a potential to go all the way to the substation if that was available at the time. In the bottom right-hand corner, you can actually see some of our team working on setting up some grid emulation at a certain project in the U.S. So how does grid emulation work? PV array provides power to the inverter. So to do grid emulation, you have to have some of the PV array completed. It's not required to have 100%. We prefer 100% to be able to test everything. But as long as there's enough PV power available for the inverter to run a minimum load, it's essentially performing the requirements of you know, having enough power available to put out AC on the other side and test as much equipment as possible. We actually set the inverter to grid emulation mode, which is a part of the firmware for the inverter. So we don't have to add special firmware. We don't have to bring in special banks of equipment on SMA side to actually perform it. It's actually done with special firmware that's already built into the inverter firmware as it comes from the factory. It has to be turned on by SMA. There's no possibility for anyone outside of SMA service personnel to actually get it to go into grid emulation mode, so it's something that we have to accomplish. The inverter is converting the DC voltage into alternating current and voltage. Power travels through the medium voltage transformer and the site cabling to the load bank. Now, like I said before, that could be all the way up to the substation. It could be just to the local block. It could be just to the medium voltage transformer that specific inverter is connected to. It just really depends on the state of construction and the setup of the site. All the PV equipment and the communications devices will be set according to the customer specifications. So during the grid emulation activity, we can actually set the IP addresses. We can verify communications if the SCADA systems are set up on the site, if there are SCADA systems installed. So we can get a good test of, you know, pretty much everything that the inverter is capable of doing if the customer has those things completed and available at the time. All the parameters will be set to the site requirements, so if there's any specific site parameters, utility parameters, those could be set. IP devices can be set. In general, it takes approximately 2 hours to perform the grid emulation of one inverter. and at that time, that includes about 15 minutes of actual power production. Now this is actual 2 hours of time where we can actually do work. This doesn't include the setup if there's multiple setups that have to get done. Generally 15 minutes is enough for people to be convinced that everything's been tested on their side. But it could be as little as 5 minutes, as long as 2 hours if the customer really decides they want to do that. Generally 15 minutes is what the customers ask for and what we see. So as far as real-world scenarios where we've had mitigation of issues, these are 3 examples of things that we've seen during emulation. These pictures don't necessarily represent those sites. They're just generic pictures, but we wanted to show them. So site 1, we had multiple customer-owned auxiliary transformers that were missing the neutral wires. We found it during the programming voltage testing before we actually ran the inverters. Several medium voltage transformers were wired incorrectly. Phases were being shared with each inverter. And this is actually a very common thing we see on the larger sites. When they're pulling the cables into the inverters from the medium voltage transformers, they're not very long runs, but a lot of times, because there are multiple wires, sometimes up to 6 or 7, up to 750 kcml cables per phase on the AC side. They do once in a while swap cables, so there'll be one cable from phase B going to, for example, phase A or phase B. And a lot of times it's not seen until we actually start the inverter. And usually when we start the inverter, it's when it's very close to COD or final completion. And this actually saved quite a bit of rework before the customer went COD and final completion. Communications issues, multiple communications issues with the DAS and ESTOP is a very common thing. I would say probably 95% of all commissionings we see communications problems with wrong IP addresses, SCADA issues, dash issues, etc. DC issues are another very common thing. I would say I've never had a commissioning where we haven't had DC issues show up when we go to start up or commission an inverter. So we were able to find those problems before the system went live, and we were able to mitigate those issues. Second site, the PVCS wires were landed incorrectly. It could have been a huge safety risk. Multiple transformers had wiring issues, phases being shared again. Multiple aux transform issues, something that happens all the time. Combiner box issues that showed up when the inverter started producing power. And then the site 3, same thing, again, transformer, missing fuses, aux transformers wired incorrectly, communications issues, DC issues. So like I said before, usually we have a 100% record of finding issues on every single grid emulation event that we've done so far. And a note in the bottom, in all cases, the COD was achieved ahead of schedule as a result of the grid emulation, and anywhere between 7 to 30 days savings in being ahead of COD and final completion. So it could be a huge number if there's bonuses, bonus structure set up for early COD. As far as grid emulation, that's all I have to share with the group. If there's any questions, feel free to ask. I'll do my best to answer as many of them as I can. One thing I will say is I can't go into specifics about customers or projects that were done, but I can talk in general terms and things we found and any other questions that may be out there. Thank you.
Thank you, Jamie, for a great presentation. Good to have these real-life examples as well. At this point, I have one question coming in. It's not specifically related to grid emulation, but I guess you can provide an answer. Let me read it up. When at the end of the day, when the sun sets, some of the voltage is drawn by the solar panels from the power grid. What can we do for that time of quick disconnecting? I'm just reading it up, so it might be not a perfect sentence. But what can you make of that, and how can you answer that question?
I don't really understand the background of the question, unfortunately. It's not that I can answer because I don't understand where that question is going.
Let me try one more time to shortly rephrase it. End of the day, when the sun sets, there is voltage drawn by the solar plant from the power grid. what can be done in terms of quick disconnecting? What's your experience with that?
I think what it sounds like is the question is related to auxiliary loads that the PV plant is drawing at nighttime.
Mm-hmm.
You know, that's something that's always going to be there. You know, it's not a normal thing to have, especially a large PV plant, to not draw some type of power during the nighttime. Generally, that's because there's, you know, lighting, fans, heaters that may have to be on to keep humidity down, and inverters or, you know, devices, SCADA systems have to be running so that in the morning time when the sun comes back up and the plant has to go grid connect, that everything is being monitored. So, you know, really there's not much that can be done. I guess the best thing that, you know, a design could have is just to minimize those losses.
Okay.
There's not really a way to get rid of it.
Okay, thanks for addressing that. Two more short questions. Let's try to go for a short answer where possible, Jamie. Do you also simulate grid disturbance incidents? And of course, this does relate to the grid emulation you just explained. We normally spend a full day verifying anti-islanding, VAR, provision, restart, etc. So the question is, do you also simulate grid disturbance incidents?
Normally we don't. Normally as part of grid emulation, we're not actually, you know, testing anti-islanding. That's a feature that's normally done after COD, or, you know, either before COD or final completion, but it's not generally done during grid emulation.
Okay. How often are your customers avoiding penalties or gaining bonuses from performing grid emulation? Can you give an indication?
Well, I can tell you generally 100% of the time that you know, if they don't meet their COD or final completion, there's going to be some liquidated damages. Sometimes there are bonuses in place for being early, but I haven't seen too many EPC contracts that don't have some type of penalty for not meeting the dates.
Okay, so it's more like preventing and avoiding penalties rather than gaining bonuses. Last question for now. Let's see if you can answer this one. Seems like a lot is involved with grid emulation. Approximately how much does this cost? We could expect that question, Jamie. What can you say about that in a webinar? Because of course it will be very case specific.
Well, I don't get involved in the sales part, but the customers that have done this have all said it's well worth the cost that's involved in doing the grid emulation.
That's a very good and politically correct answer. Very last question. What is the smallest size plant you have done this on?
I think the smallest plant that was done was probably 15 or 20 megawatts, and realistically, there's no limit to the size, either large or small, of the plant that can be done. It has to do with the financial benefits and the cost of getting the equipment rented and the people out there to actually do the work. So it's all you know, it all depends on the financial consequences of the size of the plant and you know, the numbers behind that. So there's really no limit, but I think 20 to 30 megawatt is the smallest one we've done so far.
Okay, clear. Thanks for answering these questions later on. Other questions, we will pass them on to you after the webinar, and I want to thank the audience for sending in their questions. Keep on doing that. We'll do our best to address yours. Jamie, we'll hear you in about 15 to 20 minutes when we discuss further on the end of life phase. But first we switch to the operational phase where Stephanie will present what with First Solar experience are the key issues and best practices. Stephanie, I'm going to make you presenter and muting you. Let's see how that works.
Great, let me know when you can see my screen.
Okay, we can hear you and you should have the request for your screen. We can see your screen. Go ahead.
Excellent, great. First of all, thank you, Jamie. Very informative presentation there and very similar to what we experience in the field as well, so appreciate that insight. So let me start with a brief introduction. Again, my name is Stephanie Padgett. I'm the Director of Sales for First Solar Energy Services. We provide O&M services for utility-scale PV plants for both First Solar developed projects as well as third-party projects. So let me start by providing you a brief introduction of the perspective that I'll be speaking from today. So I have just 2 slides on First Solar, and then we'll dive into the content that we're here to listen to. So GTM Research named First Solar Energy Services as the world's largest PV O&M provider for utility-scale plants for the past 2 years now. We are part of First Solar, and we're backed by the solar industry's strongest balance sheet. Our technology and staff manage over 10 gigawatts of utility-scale PV plants. Over 4.5 gigawatts of these plants are operated by our O&M staff around the world. Our supervision platform, called PVGuard, was named by GTM Research as the #1 monitoring software for utility-scale PV plants globally. Our operations centers are deployed in 4 locations around the world and use state-of-the-art technology together with our expert staff and our processes. Our performance engineering capabilities are at the leading edge of the industry and allow investors to enjoy higher plant performance and higher asset returns. We're currently running utility-scale PV plants in over 35 countries, and our fleet has been performing at more than 99.5% availability for the past 4 years, and this includes plants deployed as early as 2009. So First Solar is 100% focused on large utility-scale plants. This slide represents that experience. A large majority of the plants we operate are over 20 megawatts DC, representing 68% of the plants and accounting for 97% of the managed capacity. We also manage some of the largest plants in the world, which include Desert Sunlight and Topaz, which both are 550 megawatts AC. Okay, so let me start by sharing some things that we've learned over the past 6 years. So I've got about 20 minutes, which means I can only touch on really the surface. There's a lot of things within O&M best practices that I wanted to cover that I won't be able to, but I would love to dive into more details with each of you and would be happy to discuss directly, and I'll have my contact information at the end of the presentation for your use. So for this webinar, I'm going to focus on 3 core components of our O&M program. That's operations, performance engineering, and maintenance. So we'll start with operation. So in First Solar's Operations Center, we focus on maximizing energy yield and asset integrity, utilizing best-in-class systems and fleet lessons learned. So if you're thinking about setting up your own operations center or becoming NERC compliant, there are things that you need to consider. So first of all, 24/7 coverage is a NERC requirement for utility scale plants. So we supervise plants and respond to customer and grid operator calls around the clock. Our real-time data allows us to detect issues as they occur. Maintenance work orders and customer notifications are issued within minutes of any plant event that causes downtime. Our operators can control active power, reactive power, and other plant output parameters per grid operator instructions. And we can generate accurate production forecasts for grid operators based on advanced weather and plant behavior models. So I'm going to pause there for a moment just to remind myself that there are people out there. And we're going to move to a poll question. I think we have our first one. Is that correct?
Yes, that's correct, on the NERC requirements, right? I'm asking
yeah, I think this one's actually the GSU, which will take us into the next slide.
Okay, let's see if we can pull it up right now.
Okay.
Yes, go ahead. So in the case of a GSU event, how many cascading alarms would this one event cost for, in this case, a 20 megawatt plant? Stephanie, GSU stands for?
Generator Step-Up Transformer.
Thank you. At options, people can choose from between 20 and 50 alarms, between 50 and 100, or even more than 100. We look forward to what people think, so you can choose right now. Let's give a couple of seconds for this to see what people think. And I'm curious to see if the experience or what people expect is in line with your experience, Stephanie. Good. Let's. I think most of the people might have voted by now, so let's take a look at the results. And I'm curious for your thoughts on this, Stephanie. So it's quite well divided, actually. Roughly 1/3 thinks all the 3 options. And I'm curious to hear from you what is your reality.
Right. Yeah. Actually, in that one event, we would see over 100 alarms, which kind of takes me into the next slide.
Okay.
So in order to operate and control our 4 gigawatt fleet, it is essential that we receive real-time data, meaning 1-second data, into the ops center. In order to handle the amount of data this generates, it is key to develop a high-level alarming system. Just having a bunch of SCADA screens open does nothing to help the operators with situational awareness. The operators need to know what are the most pressing issues and then use the SCADA system to help confirm or diagnose the problem. You also need a way to manage or prioritize these alarms. Okay, so for the example of the GSU, when this happens, that incident alone would cause a cascading alarm event that would generate a massive amount of alarms, so over 100 alarms. And the operators would then be buried in alarms and unable to identify the one that matters. In this case, your alarming tool needs to be able to weed out all of those alarms and only find the one that matters. You also need notification tools in place. So your PPAs require that your operator contact the utility, balancing authority, and scheduling coordinator if a certain number of megawatts or inverters go offline. It's impossible for our operators to know those thresholds for over 56 plus plants. So there needs to be a way to clearly see or respond to this requirement. So this is where we bring in our Fleet View system, which allows our operators a clear visual of plant details, real-time generation, and component alarms. Our site information widgets allow the operators to monitor site information without getting into the SCADA. And then those can be customized depending on the operator's needs. And then we have forecasting widgets that allow us to track our forecast compared to actual. So production scheduling and forecasting are required by many utilities or grid operators and mandatory requirements in many PPAs for utility scale projects. We start with a satellite weather forecast, then we calculate an irradiance forecast, and then from that, this serves as an input to our energy forecast that models the plant's output based on incoming irradiance and then adjusted to the outages. The final forecast is then delivered automatically to the utility or the grid operator. So with a with a central plant control system, the inverters are dynamically controlled and do not require a fixed limit. So when needed, in some inverters, output is limited due to cloud cover. As you can see, I'm sorry, let me take you back to that illustration. I wanted to walk you through it again. Here we go. So when there's cloud coverage, the controller will utilize the other inverters to produce more, having less of an impact on the power generation of the plant. So how much impact this will have on the yield is not easy to estimate, since it depends upon numerous factors, including the output limit versus the excess capacity, weather conditions, and some other items there. But this is a vital feature when we optimize the plant design and use certain level of overbuild on the AC side to yield the maximum over the plant's life cycle. So a plant controller is also needed for real power output curtailment of the solar plant, so when required. so that it does not exceed an operator specified limit. It also provides ramp rate controls to ensure that the plant output does not ramp up or down faster than any specified ramp rate limit. Let's see. Another key component to our operations platform is that we log all plant activity and maintain these records for the full life of the asset. So all this information is available for our owners. This is also a regulatory requirement. All conversations between operators, technicians, utilities, and grid operators must be logged, and this is a NERC requirement. So I'm going to pause here again, and I think we have a poll question that's related to NERC, and that'll bring us into the next conversation.
Excellent. Here you go. There are 35 NERC reliability standards for the generator owner, let's call them GO, and 29 for the generator operator, GOP. How many of these are shared between them? And this might be a difficult question, but if you don't know, what do you think? Will this be 3, 7, or 11 out of the 35 and 29? Please give your vote right now, and we'll be waiting a couple of seconds for to see what you think. Okay, let's look at my colleague to see how far we are. Okay, yeah, let's look at the answers so far. Most people think this is 7 shared between them. Stephanie, is this correct, or is it logical reasoning? Go ahead.
Yeah, so this question was really just to get a feel for the audience and how they're thinking about NERC. The answer is 11. We spend a lot of time analyzing these requirements. Obviously, they're key. We currently have 10 facilities that fall under the NERC requirement. So this is something that we are spending and dedicating a lot of time on. So again, the answer is 11. So that brings us into NERC, and I'll spend just a couple of minutes on how this plays a role in our best practices. So FERC, which is Federal Energy Regulatory Commission, and NERC, North American Utility Reliability Corporation, regulate reliability and security of the grid in North America. FERC issues the orders, and then NERC is in charge of creating and enforcing the standards. So the exact scope of compliance requirements depends on the impact level of each facility, as you can see in this table. Currently, only large facilities over 75 megawatts AC are in scope, but the threshold is expected to lower and could be as low as 20 megawatts sometime in the future. Any operation centers that act as a generator operator for a low-impact facility must be NERC registered, and this entails compliance with about 10 security standards as well as 30 reliability standards. Penalties can be as high and can reach up to $1 million per violation per day. The asset owners are liable for such fees. If you operate the plant, you're considered as the generator operator and will be responsible for violations related to the operations of the plant. So one of the key requirements of a NERC facility is the training and procedures program, which is covered on the next slide here. So all of our technicians and O&M support staff complete rigorous training. We're doing a NERC overview, bulk electric system training, NERC standards training, all part of the training program within First Solar. So NERC standard, which you may or may not be familiar with, SIP 4-5 is the critical infrastructure protection requirements. And they have specific training requirements that if you cannot clearly demonstrate that you meet all the requirements during an audit, they would then result with a fine. So we spend a lot of time training our staff and a lot of time making sure that we have adequate documentation that can prove that as well. Okay, so I have covered operation, and we're going to move into performance engineering. So performance engineering is an activity that combines expert staff, advanced technology, and processes to analyze extensive plant data in order to optimize the performance of a plant and the cost of the O&M activity. So performance engineering is distinct from ongoing plant supervision because it aims at detecting subtle issues that usually do not trigger alarms and at predicting future faults before they occur. Performance engineering is a common and well understood practice in the wind industry, but it's still in its infancy in the solar industry. So predictive maintenance recommendations that are a result from performance engineering improve efficiency in your maintenance as well as prevent catastrophic failures by improving your PM schedule. So I have a couple of examples of how we use performance engineering, and then we'll talk about the benefits that it brings. So when I refer to predictive maintenance, I'm not referring to knowing when to clean the dirty modules. There's really nothing predictive about that. Predictive maintenance means knowing that a piece of equipment, like a transformer or an inverter, is about to fail before it fails, so that the maintenance crew then can perform condition-based maintenance or PMs that prevents the failure. Predictive maintenance involves minimal planned downtime, whereas catastrophic equipment failure translates to significant and unplanned downtime. And then predictive maintenance costs are usually low, whereas catastrophic equipment failures lead to expensive repair or replacement of the faulty hardware. So this slide includes two common examples of predictive maintenance, one for IGBT overheating, leading to the inverter failure. And then the other one is an oil leak leading to a transformer failure. In both cases, performance engineering detects the issue ahead of time and then enables a resolution that avoids downtime and energy losses and replaces expensive repairs with minor ones. So without performance engineering, most DC issues remain undetected until the next physical testing of the array, which is either through thermal imaging or string test, and typically happens on an average interval of 6 to 12 months. With performance engineering, we perform daily DC array health checks, so resulting in continuous commissioning of the array. Performance engineering also provides reliable detection of these DC issues because software algorithms are not subject to the blindness that comes with technicians inspecting thousands and thousands of strings and modules as they walk through the plant. Okay, so let's look at the simple scenario of a soiled pyrometer. It compromises the entire chain of trust upon which investors and asset managers rely for accurate performance data and informed decision. Rather than trusting that people will clean the sensor when it may benefit them not to clean it, investors and owners should trust automated processes and algorithms that check sensors and report anomalies. This is another way that we are using our performance engineering to better support our customers. So as demonstrated, performance engineering provides a series of benefits to our asset owners and should be a part of your O&M program for the reasons captured here. So capital expenses are reduced via prevention of catastrophic failures and replacing expensive corrective maintenance by efficient predictive maintenance. Availability is improved via replacement of large unplanned downtime for equipment repairs by small planned downtime for condition-based maintenance. Plant performance is optimized via remote continuous commissioning of the power plant's DC array. Issues are detected without having to wait for the next on-site combiner, string, or module testing. And plant operators, asset managers, and investors can make better decisions by relying on accurate data. Continuous remote check of sensor leads to accurate performance reporting and optimum cleaning schedules. And then we have monthly reports and performance reviews ensure that stakeholders have full visibility on all of the pending issues. Okay, and last but definitely not least, the maintenance. And this is really the boots on the ground. Maintenance activities are needed of the entire power plant, so that's including both the DC side as well as the AC side. So our work does not stop at the inverter. We also maintain the transformers and the medium and high voltage equipment. We manage spare parts, so we go beyond ordering and inventory. We also manage the supply chain. For example, for many brands of inverters, we are able to source OEM components directly from the manufacturer that supplies them to the inverter company. So this allows us to better serve asset owners in case the inverter company faces bankruptcy. They could decide to exit the market or just have spare part delivery issues. We work closely with utilities and grid operators in order to schedule maintenance activities in a way that reduces impact on grid operations to minimize production impact from preventive maintenance activities. We perform those activities at nighttime instead of during the generation hours. O&M planning involves many different activities and people. While every component of the solution is important, the key to a world-class quality of service is actually the seamless integration between these different components, from the operations center and the performance engineering to the maintenance technicians, spare parts, and suppliers. This is why First Solar has invested heavily in process automation and integration. Our O&M team uses advanced computerized maintenance management systems that connects the various stakeholders and automates processes for optimum speed, efficiency, quality, and consistency of service. So what I'm going to do is I'm going to walk you through how we use this system. For example, let's examine the flow of actions and events that occur in the event of a fault at the plant. So the SCADA system detects the fault and fires an alarm automatically. An operator in the operations center reviews, confirms, and diagnoses the fault and creates the work order. The work order is prioritized based on the associated energy and revenue loss. The CMMS assigns the work order to a technician based on geographical location, proximity, availability, and skill set, automatically calculating and optimizing the service routes. The system also makes sure that the right spare parts are available and reminds the technician to bring them on the job. The technician performs the repair work on site and uses field automation software on a tablet computer to update the work order status and then enter information that can later be used for maintenance records, reporting, for feedback loop that drives continuous improvements in our processes. The CMMS automatically updates the spare parts stock, and it can also reorder parts if inventory is low. And then the system also notifies the operator of the repair so they can verify that the original fault is indeed resolved, close the work order, and then verify that any availability impact is accurately captured. So you'll notice that 8 of the 11 steps are automated, while only 3 steps are still manual. Our approach is to automate every process that can be reliably automated so that our experts can focus on higher value tasks that require judgment and expertise beyond the capabilities of the software program. So really, hopefully, what I've demonstrated is that this kind of automation yields many benefits for asset owners. Automation accelerates execution of most activities and allows us to provide faster and more reliable response to the issues. Prioritization of work orders by energy and revenue loss ensures that our maintenance crews are spending their time in a way that optimizes investor returns. From an execution standpoint, software automation and automation allows us to reach high levels of staff utilization via optimization of crew loading and service routes. And then our CMMS system keeps our technicians from showing up to resolve a fault without carrying the right tools or spare parts, which would have resulted in wasted resources, increased maintenance costs, also while reducing plant performance. By capturing the relevant information at every step, we collect valuable data, which can then be leveraged in the form of maintenance activities, component reliability studies, but most importantly, the improved annual maintenance plans and schedules. Which takes me into my final slide, planning and scheduling strategy. So in order to minimize annual O&M costs, preventive maintenance should be justified as required to maintain system efficiency, avoid more expensive replacements, and maintain equipment warranties in an effort to maximize rate of return considering the entire life cycle. PMs maximize system output, prevents more expensive failures from occurring, and maximizes the life of the system. So PMs, though, you have to they must be balanced by financial cost to the project. So therefore, the goal is to manage the optimum balance between the cost of scheduled maintenance, yield, cash flow through the life of the system, and other components as well. So PM protocols depend on the system size, the design, the complexity, the environment, and should be developed on a per plant basis. The OEM PMs that are out there, we've used those to originally set our baseline, but based on the data of our fleet over the last 6 years, we've then been able to adjust that PM plan to help increase plant availability and increase efficiency of our maintenance crews, and that's really where we've been able to drive down the most significant costs in our overall O&M program. I think that was it. Yes. So that brings me to the end. Here is my, my contact information. I know there's a lot that I didn't cover. Hopefully we still have time for some questions. But I will be at Solarplaza Asset Management Conference, and please feel free to seek me out if you have any questions that we don't address here.
Thanks a lot, Stephanie, for your presentation. Because of time, I would propose I'll still wait for questions coming in. Let's have time for one question, although we're already seeing my end of life slide. Maybe you can give a short answer. What percentage of your plants are CSI versus thin film? For CSI modules, have you seen catastrophic failures? And if so, what has been the cause? And what have you been able to do to address the problem? Go ahead.
Yeah, so the majority of our fleet, our current fleet, has been thin film, the 4.5 that I had mentioned, but we have done a lot of work with silicon modules as well. It plays a big role in our fleet when we look at it globally. So we do have a lot of experience on that side. Really, the issues that we're seeing in the field have been inverter related, and we haven't really seen any catastrophic issues that the question kind of spoke to. But there have been problems that we've had to address and get resolved across our inverter fleet.
Thank you, Stephanie. First solar maintenance technicians, are these first solar employees or local subcontractors? Is one other question, and I think it's quick to answer.
Yes, the majority of the maintenance being performed for our customers is all in-house for solar employees.
The majority, can you explain which part not, or not entirely?
Yeah, currently all of it. We have been looking at growing into other regions where we don't have significant resources. So in those areas, we have been looking to partner with with maintenance providers that have a strong reputation in those areas and bring a lot of value to our structure and our strategy.
Okay, fair enough. Let's take still some time to address the end of life phase, and I would like you and also our audience to imagine plants being 15, 20, maybe even older than this, and let's brainstorm a bit about the issues there. But as an introduction to these questions, I would like to ask both you, Stephanie, and Jamie, for your opinion. What is the typical
Unmuted.
design life of plants that are currently in operation? Would you say it's 20 years or even more? Jamie, you there? Let's start with your thoughts on this.
Yeah, I think
Muted.
5 to 10 years ago, I think a lot of the designs probably were at the 20-year point. But I think as time has gone on, what I've seen is those plans have usually gotten to the 25 or 30 plus year point. It really depends on the financial and the impacts and what was built in, as well as if there's any property leases or what the local jurisdictions have outlined. So I think in general it's starting to go higher, and I think it's probably getting closer to 30 at this point.
So you would say plants coming online now as we speak could be operating until 2046, maybe.
Yeah, I would say that. Yeah, I would say that that's a good estimate.
Okay, Stephanie, do you agree here, or do you have a different vision?
I do agree. I mean, what we're obviously learning more every day about how these plants will perform in later life, and only time obviously will tell. But we don't see any indication that at year 25 or 24 that the plant just stops performing, right? So there's going to be a gradual phase there, and looking at these assets to potentially last for 30 years is definitely a possibility.
Okay, well, we don't have a poll about this, but I would be curious if the audience has questions here, and I would encourage people to ask their questions still as we talk. Let's see how the next question here. Decommissioning requirements. So let's again imagine we're already talking about decommissioning in 2046. Or now let's talk about the current situation. What are current decommissioning requirements, and who defines these? Stephanie, let's start with you. What is your experience, or what are your thoughts here?
Yeah, I think there's still a lot that the industry needs to understand and start to recognize is going to be part of a decommissioning phase. I know that there are, at least from the panel side, First Solar has a recycling program where it actually enables them to use very high percentage of the components, the material within the modules, and can recycle those to produce new modules. So I think there's going to need to be programs like that across the board, and whether that's driven by the manufacturers themselves or maybe potentially the other parties involved. I think that's that's a question to ponder. Not quite sure on the answer there.
Okay, thank you. Jamie, what are your thoughts here? What requirements do you see, and who are defining these, or who will be defining these?
Yeah, as far as decommissioning requirements, I think Stephanie's answers are probably very close to what mine are. I think the easy part is getting rid of the hardware, as far as cabling and inverters and racking, substations, those are relatively easy things to handle. I think the modules and the panel recycling or disposal is going to be the most difficult part of it. What I've seen as far as plants that we operate or maintain, or I've seen the agreements that are out there with the jurisdictions, there's a lot of focus on getting the land back to the original condition, and it seems to be less focus on the physical assets on the site being taken care of. In my view, I think getting the grounds back to the state they were before, is a relatively easy process. I mean, it's not something that that isn't done all the time, so that should be simple. And getting rid of cable and hardware is easy. And I think there needs to be more focus on what to do with the panels. And luckily, First Solar being on this conversation, they're a good steward of that, and they have good processes in place to handle that. But I think there's probably a lot of gaps in other manufacturers that haven't thought about that. I think we're going to get to a point here in probably 15 years where plants start getting decommissioned, and maybe even 20 years, and there's going to be significant amounts of old panels that are going to have to be disposed of properly, and I think it's going to be a big issue that it's right now it's not being looked at heavily, but I think it's going to become a problem as we get farther down the road.
Okay, Jamie, back to the earlier statement, or let's say expectation, 30-year lifetime of a plant. Are you seeing PPAs being extended to these life cycles? Maybe not now, but in the future. What are your thoughts on that?
I personally haven't seen any get extended that far yet. Most of the ones I've seen are around the 20-year mark. Some are even less than that. But I can see these going out farther. It really depends on the locality, whether it's up in Canada, the southwestern U.S. States. States and countries. There's so many variables, and it really depends on the authority that has the jurisdiction at that specific location of that plant to really, come up with the requirements for extending those PPAs. I think it's very, very regionalistic.
Okay. One of the people in the audience is asking, is there a strategy to prolong the life or to help the performance towards the end of the life of the facility? Are you guys already working on this? Jamie, let's start with you, but I also would like Stephanie to comment on this.
As far as a plan to at year 22 to do a lot to get the performance up there, I really think it's a long-term, proper maintenance and performance testing that really is what's going to extend the life of the plant. Maintaining the warranties, being assertive on filing warranty claims and getting repairs done, equipment changed out when it needs to. As far as at the end of the road of a plant, I think it's too little, too late to try to make the thing, spit out its last megawatt hours at the end without spending a lot of money. I think it's just a long-term approach to doing things correctly is really what's going to keep it going and producing as much as it can for as long as it can.
Thank you. Stephanie, does First Solar have a specific strategy to prolong the life, to help the performance towards the end of life, or would you agree with Jamie on this?
I do agree with Jamie, but also I think one of our biggest challenges that we're trying to get ahead of is as the equipment starts to age, it really becomes there's a variety of different equipment manufacturers that are out there that probably won't be out there in 10 plus years. And how are we going to then address the repairs and the issues, a cost-effective way so that we can continue to maintain those PMs to get that 20, 30 life out of the asset. So I think putting together strategies around how you're going to address that now is really key to making sure you keep that performance level.
Absolutely, yeah. One of the topics that we will deal with at the conference as well. Another question that comes in asks, so another person asks, at the moment, what is the decommissioning cost planned for a PV plant per, let's say, per megawatt installed? Again, we're not there yet, but what can you say about this? Stephanie, let's start with you.
Yeah, from my perspective, I'm not sure I'm probably the appropriate one to give estimates or give generalizations on what the cost is. I'm not sure that I really know.
Okay, fair enough. Jamie, are you the right person? No, but what are your thoughts on this? I mean, estimation maybe even goes a bit far, but what do you think could be the range per megawatt of decommissioning costs?
I wouldn't even begin to guess. I know there's every investor, every owner, has their model and their thoughts on what those costs might be. From my experience, when you're trying to estimate something that's really not been done before and it's 25 to 30 years down the road, there's probably a lot of things that are just wild guesses. I'm sure there's some analytics behind it from other things, but I wouldn't even begin to know. It's more of an investor and owner type question, but at the same time, knowing how accountants have to do things, I would think it's probably more of a wild guess than anything else.
Okay, so far hard to say anything, to even make a guess about this. Jamie, another question that comes in and probably is the best for you. Do inverter manufacturer, in this case SMA, foresee taking an accountability role in the performance or production guarantees? Yeah.
Generally as an inverter manufacturer and equipment manufacturer, we're limited to a certain piece of equipment that's installed with an overall design and many other pieces of equipment that affect it. Generally, we don't get involved very heavily in performance guarantees and ratios. We do offer availability guarantees, availability of the inverter, but as purely if we're just talking an inverter manufacturer, it's not something that's really a risk that we would even consider taking, because there's so many other factors that are beyond our control that are involved in those type of things.
I can imagine. But is it a question that you get asked every now and then, or the expectations are not there?
Yeah. I mean, we do get asked that question. I mean, our warranty is pretty good about what we offer and what we provide. And like I said, we do offer availability guarantees for the inverter. In certain instances and circumstances, it's asked. As an inverter manufacturer, as an O&M provider, it's definitely something that's out there more often as an O&M provider on the other side. But inverter manufacturer is kind of hard to guarantee those type of things.
I can imagine. Okay. Fair enough. I'm looking if there are any other questions coming in now, but we're also running out of time. So I think this is it. There will definitely be questions afterwards. So I'll make sure to forward these to you, and I would like to encourage the audience to send them through. For now, I would say a big thank you to our speakers. Jamie and Stephanie, thanks for taking the time to prepare this and share with us. I look forward to meeting both of you in exactly 4 weeks in San Francisco at the Solar Asset Management North America Conference. We will be in touch before then. I hope to meet people in the audience there. And as mentioned, any questions, feel free to reach out to me afterwards. Have a great day or a great evening, depending where you are, and look forward to meet you soon. Bye-bye.
Thank you.
Bye.